So in these notes, we're going to be talking about how to do dilations in the coordinate plane. So dilations are transformations that make figures bigger or smaller through enlargements or reductions. When we dilate figures in the coordinate plane, it is always centered at the origin, so you might see that written in the problem. And to find the scale factor for the dilation, we divide the coordinates of the image by the coordinates of the pre-image. So for 1 through 6, we're going to determine the scale factor and then state whether it was an enlargement or a reduction. So our first step is to pick two corresponding points on our image and pre-image. So I'm going to choose M prime and M. M prime is located at 6, 6, and M is located at 3, 3. So we're going to take either the x coordinate or the y coordinate. It doesn't matter unless it's 0. We can't use 0. And we're going to divide the image coordinate by the pre-image coordinate. So to find the scale factor, we're going to divide 6 by 3, and we get 2. 2 is greater than 1, so we know that this is an enlargement. And we can check that and see that the figure does get bigger. So this is our pre-image here. So from our pre-image to our image, it does get larger. Number 2, I'm going to choose I prime and I. I prime is located at -6, 9. And I is located at -2, 3. So we're going to take the image coordinates and divide it by the pre-image coordinates. So again, it doesn't matter if you choose x or y as long as it's not 0. So we're going to do 9 and 3. So our scale factor, which I'm going to shorten to SF, so that's scale factor, is 9 because that's the image coordinate divided by 3. That's the pre-image coordinate. So our scale factor is 9 divided by 3, or 3, which is an enlargement. This makes sense because to go from the original figure to our image, it had to get larger. Number 3, I'm going to choose H and H prime. H is located at -9, 3, and H prime is located at -3, 1. So we can choose either the x or the y coordinates, doesn't matter. So I'm going to choose the y for this one. And our scale factor will be the image coordinates, which is 1, divided by the pre-image coordinates, 3. So our scale factor is 1/3, which is less than 1. So this is a reduction. This makes sense because to go from the original figure to our image, it had to get smaller. Number 4, I'm going to choose E and E prime to show you why we cannot use 0 when determining our scale factor. So E is located at 4, 0, and E prime is located at 2, 0. So to find our scale factor, we have to divide the image coordinates by the pre-image coordinates. If we were to choose our y coordinates in this case, which are 0, we will get 0 over 0, which is 0. And we know that that is not the case. So whenever you have 0 as coordinates, you cannot use them to determine the scale factor. You have to use the actual values. So we're going to take the image coordinate of 2 divided by the pre-image coordinate of 4. So our scale factor is 1/2, which is a reduction. And we can see that this is a reduction because to go from the original figure to the image, it had to get smaller. Number 5, we're going to choose 2 points, y prime and y. Y prime is located at 2, 6. Y is located at 1, 3. So I'm going to use the x coordinates for this one. So our scale factor is going to be our image coordinate divided by our pre-image coordinate, or 2. This is an enlargement. And we can check to make sure it is an enlargement because from the pre-image to the image, we had to make the figure larger. And finally, we have, let's use u prime and u. So we have 8, 0, and 2, 0. And remember, we cannot use 0 when determining the scale factor. It will not give us the right number. It will just give us 0. So we're going to use our x coordinates of 2 and 8. So 2 is the coordinate for our image, so that goes on top. And 8 is the coordinate for our pre-image, so that goes on bottom. So 2 over 8 simplifies to 1/4. Because the scale factor is less than 1, this is a reduction. And we can check to see if it's a reduction because it goes from our larger figure and it has to get smaller to get to our image. So on the front of this sheet, we were determining the scale factor based on figures graphed in the coordinate plane. On the back of this sheet, we are applying a given scale factor to points and figures. So this table, it says, what is the image of each of the following points after each dilation centered at the origin? So these points here are our pre-image points. So these are the pre-image. And what we're going to do is we're going to apply each dilation to each individual point. So our first point that we're starting with is 6, -3. So to apply a scale factor to a given point, we multiply each coordinate times the scale factor. So on number 1, our coordinate is 6, -3. So to find the image coordinates, we're going to multiply both coordinates times the scale factor. So we have 6 times 1 and -3 times 1. So our new coordinates are 6, -3. So with a scale factor of 1, nothing changes. So the figures are still going to be congruent. Now we have a scale factor of 1/3, which is going to be a reduction. So we're going to take our coordinates, multiply them times the scale factor. So 6 times 1/3 and -3 times 1/3. So 6 times 1/3 is 2. -3 times 1/3 is -1. Our next scale factor is 2, which is an enlargement. So we're going to multiply each coordinate times our scale factor. So we'll say 6 times 2 and negative 3 times 2. So our image coordinates are 12, negative 6. And our last one is a scale factor of 2/5. This is a reduction because 2/5 is less than 1. So we're going to say 6 times 2/5 and negative 3 times 2/5. So we get 2.4 for our x coordinate and negative 1.2 for our y coordinate. Now we're going to move on to the next point, which is negative 312. So we're going to follow the same pattern. And I'm just going to go through and fill these out with the correct answers so you can follow along with me, or you can pause it and work these and then move ahead to check the answers. All right, the next thing we're going to do is graph dilation. So we're given the pre-image and we're given the scale factor, and we need to determine the coordinates of the image. In order to do that, we first need to know what the coordinates of the pre-image are. So number 5, we have a scale factor of 1/3, and this is a reduction. And whenever we have any type of transformation, we can write a coordinate rule to represent that transformation. So we did this with rotations, reflections, translations, and now we are going to do it with dilations. So we know that with dilations, we take all of the original coordinates and we multiply them times our scale factor. Our scale factor for this problem is 1/3. So our coordinate rule is going to look like this. For every x and y coordinate in our pre-image, we're going to multiply x times 1/3 and multiply y times 1/3. So that is what our coordinate rule looks like for dilations. So we're going to find all of our coordinates in our original figure, our pre-image. We're going to multiply all those coordinates times our scale factor, and we're going to plot our image. So H is located at 6, 6. G is located at 0, -6. And I is located at -6, 3. So we're going to multiply all of our coordinates times our scale factor of 1/3. So I prime, we're going to do -6 times 1/3 and 3 times 1/3. So just like we did above in the table. So I prime will be located at -2, 1. Next we have H. So we're going to do 6 times 1/3 and 6 times 1/3. So H prime will be located at 2, 2. And then G, we'll say 0 times 1/3 and -6 times 1/3. So G prime will be located at 0, -2. All right. Our next one, this has a scale factor of 3. So this is going to be an enlargement. And our coordinate rule looks like this. For every x and y, we're going to multiply x times 3 and y times 3. G is 1, 2. H is -1, 2. And F is 0, -3. We're going to multiply all of these. So G prime will be 1 times 3 and 2 times 3. So G prime will be at 3, 6. H prime will be at -3, 6. And F prime will be at 0, -9. Number 7, our scale factor is 2. This is an enlargement. Our coordinate rule will be for every x and y, we're going to multiply x by 2 and y by 2. So we need to find our coordinates. M is 4, 0. L is 1, -4. N is -1, 2. and O is -3, 1. We're going to multiply all those times our scale factor of 2. So N prime will be located at -2, 4. O prime will be located at -6, 2. M prime will be located at 8, 0. And L prime will be located at 2, -8. And our last one, we have a scale factor of 1/4. This is a reduction. Our coordinate rule is for every x and y, we're going to multiply our x times 1/4 and our y times 1/4. So F is -8, 8. E is 4, 8. B is -4, -8. C is 0, -8. And D is 8, -4. So we're going to multiply all of our coordinates times 1/4. So F prime is going to be -2, 2. E prime will be 1, 2. D prime will be 2, -1. C prime will be 0, -2. And B prime will be -1, -2. So in this video, I'm going to talk about what happens to measurements of figures under dilations. So specifically, we're going to talk about side lengths and angle measures. So in dilations, our side lengths are going to change. So when we apply a dilation to a figure, the size of the figure is going to change. So the side lengths change. But under dilations, our angle measures are going to stay the same. So angle measures stay the same. They do not change. So the image and the pre-image will have the exact same angle measure. Number 1 states that line segment DE is dilated by a scale factor of 5 to form line segment D prime E prime. If D prime E prime measures 85, what is the measure of DE? So in order to solve this problem, we're going to set up a little visual, a little equation, so we can see what exactly is going on. So we know that line segment DE has to be multiplied times a scale factor of 5, and then we're going to get line segment D prime E prime. The information we are given in the problem is the length of D prime E prime, which was 85, and we were given the scale factor of 5, but we were asked to find the length, the measure of DE. So we need to figure out what number we can multiply times 5 to get 85. In order to do that, we're going to divide 85 by 5. So the measure of DE is 17. Number 2, it says that angle OPQ, or O prime P prime Q prime, has a measure of 100 degrees. It's dilated by a scale factor of 2, and it wants to know what is the measure of angle OPQ. We know that under dilations, our angle measures for our image and our pre-image are the exact same. They do not change, so the measure of angle OPQ is the same as the image, which is 100 degrees. Number 3, this says that this is the image P prime Q prime after a dilation by a scale factor of 4, and we're looking for the measure of PQ. So we know that we're going to multiply PQ times 4 to get P prime Q prime. In the problem, we are given the length of P prime Q prime right here, which is 36. And we are looking for the length of PQ. So we need to figure out what number we multiply times 4 to get 36. To find that number, we will divide 36 by 4, and we get that PQ is 9. Number 4, YZ is dilated by a scale factor of 6 to form Y prime Z prime. If Y prime Z prime measures 30, what is the measure of YZ? So YZ is multiplied times a scale factor of 6, and that's going to give us Y prime Z prime. We are told that Y prime Z prime measures 30. So to find the measure of YZ, we divide 30 by 6, and we get that YZ is 5 units long. Number 5, it says the figure is dilated by a scale factor of 3. What is the measure of angle V prime, W prime, X prime? So our original angle, our pre-image, is 74 degrees. So after a dilation, the angle measure is also going to be 74 degrees because angle measures do not change with dilations. Number 6, we are given a line segment and a scale factor, and it asks us to find the measure of C prime, D prime. So we know that C prime, it's CD, line segment CD, will be multiplied times a scale factor of 5 to get line segment C prime, D prime. We are given the length of CD, which is 11. So to get C prime, D prime, we multiply 11 times 5. So the length of C prime, D prime is 55. Number 7, we're looking for the measure of FG, so the pre-image, and we're given the length of the image. So we know that FG times 2 gives us F prime G prime. We are told that F prime G prime measures 38. So we need to figure out what number times 2 gives us 38. So the measure of FG is 19. We have 38 divided by 2. Number 8, we have a scale factor of 1/4. So we know that we're going to multiply GH times 1/4 to get G prime H prime. We are told that GH measures 30. So to get G prime H prime, we're going to multiply 30 times 4. So the length of G prime H prime is 7.5. And our last one, a figure containing angle CDE is dilated by a scale factor of 2/3 to form a new figure. If angle C prime, D prime, E prime measures 136, what is the measure of angle CDE? We need to remember that when we dilate a figure, the angle measures remain the same, only the side lengths change. So if the measure of the image angle is 136, the measure of the pre-image angle is also 136.